Okay, welcome to part 3 of topic 27, Multiplication Properties of Exponents. So lastly, what we will be dealing with is this will look like the first flap on your foldable, but actually the problems that correlate with it are the inside the bottom flaps of problems. So again, I apologize for that. Thank you all for bearing with me. So this is called power of a product. Now we know that a product is basically the answer of multiplying two things together or multiplying a set of things together. So here we're multiplying A times B, and it's the power of a product because then they're all being raised to this power. So we kind of saw this in part 2. What we're doing here is we're basically distributing. So we have this M power. We're going to distribute it to every single factor in that product. So every single variable, every single number that we see in that product, we're going to distribute that exponent that is on the outside of those parentheses. So if we were to see this here, actually let me use blue again. We have 3a squared b to the 5th power, all raised to the 3rd power. So this 3 is going to apply to the coefficient of 3, to our a variable, and to our b variable. So if we want to multiply this out, we will get 3 to the 3rd times a squared raised to the 3rd times b to the 5th raised to the 3rd. I'm sorry, I should have the 3 out here. That would make more sense. So what we just learned before is that a power of a power, you multiply them, right? So if we want to simplify this, 3 to the 3rd power, this is 3 times 3 times 3. So this will give us 27. Below that, we have a squared raised to the 3rd power. So this is going to be 2 times 3. And b to the 5th raised to the 3rd power is going to be b to the 5 times 3. So if we simplify that, we get 27, a to the 6th, b to the 15th. There we go. That is power of a product. So we should be opening up the bottom flap of your foldable. And our first example is negative 4xy all raised to the 3rd power times negative 2x squared raised to the 3rd power. So right off the bat, I'm going to go in and every variable that I see that I don't see an exponent, I'm going to write a 1 just because it's a really helpful reminder for me. So now I'm going to distribute my outside exponent to every variable or coefficient inside. And honestly, I can do that for the 3 here. So if I want to rewrite this, I get negative 4 to the 3rd power times x to the 1 times 3 times y to the 1 times 3 multiplied by negative 2 to the 3rd power times x to the 2 times 3. So if we want to simplify this, if we have our coefficient here, we have negative 4 times negative 4 times negative 4. This gives us positive 16 times negative 4, which gives us negative 64. So our first coefficient of that first big factor here is going to be negative 64. If we have 1 times 3, that's going to be x to the 3rd. And if we have 1 times 3 here, that's going to be y to the 3rd. So that's our first part. Our second part, we're going to have negative 2 cubed. So that's negative 2 times negative 2 times negative 2. Negative 2 times negative 2. A negative times negative is a positive. So we're going to have positive 4 times negative 2. And then that's going to give us negative 8. So negative 8 there. And then x to the 2 times 3 is going to give us x to the 6th. So we're going to regroup these again because I'm cruel. And if we regroup our coefficients, negative 64 times negative 8, we'll regroup our x's, and we have x cubed times x to the 6th. And then last but not least, we'll have just our y, which is just y cubed. So negative 64 times negative 8, if we multiply that together, we get positive 512. You're welcome. X to the 3rd times x to the 6th. So here we have the same base. What we're going to be doing is we're going to be using product of the power, same base, we're going to add the exponents. So we get x to the 9th, and then just bring down our y to the 3rd. So that's our first example. Is it a doozy? Yes. Am I mean? That's up for debate. Okay, next problem. Let's keep moving. Negative 3 times 2x all raised to the 4th times 4x to the 5th y raised to the 2nd. Now notice here how this negative 3 is a lone wolf. It is not in our parentheses here, so hence it is not going to be raised to the 4th power or the 2nd power. It's going to be excluded. So let's make our exponents, if we don't see any. So we have x to the 1st, and then also y to the 1st there. So we can regroup this. I'm going to rewrite my negative 3 out here so I don't forget about it. And distribute or apply my exponents to every single thing. So this is going to be multiplied by 2 to the 4th times x to the 1 times 4, and then times 4 squared x to the 5 times 2, remember power raised to a power, times y to the 1 times 2. So if we want to multiply this together, we're going to get negative 3. Now 2 to the 4th is 2 times 2, which is 4, times 2, which is 8, times 2 again, which is 16, times x to the 4th, and then 4 squared is also 16, times x to the 5 times 2 is 10, times y squared. Now we can regroup, and we can rewrite. We're going to have negative 3 times 16 times 16, times x to the 4th, x to the 10th, times y squared. So negative 3 times 16 is the same thing as negative 768. X to the 4th times x to the 10th, same base, so we're going to add the exponents. X to the 14th times y squared. And there you go. That's the second example. Whew. Okay. They did not want to give us a break here. Yowza. Okay. We're getting a little bit more. So let's first write an exponent of 1 if we don't see an exponent. 2 to the 1st, y to the 1st, and yeah. Okay, now let's apply. So that's going to be 2 to the 2nd, x to the 1 times 2, y to the 1 times 2. Notice here in our second one, it's not actually raised to an exponent outside, and same with our third. So really, once we do our first one, all we're just going to have to do is use our product of powers and just notice our same bases and regroup there. So we have 2 squared times x to the 1 times 2 times y to the 1 times 2, and that is our first factor there. Our next one, we're just going to have negative 3x squared and 4y to the 4th, because again, they don't have an exponent on the outside, technically, we could write there's like a 1 here. It's not going to do anything, but yeah. Okay. 2 squared is going to be 4. X to the 1 times 2 is x squared. Y to the 1 times 2 is y squared. And then we're going to have our negative 3x squared times 4y to the 4th. So now what we're going to do is we're going to regroup our coefficients. So I have my 4, my negative 3, and my 4 here. So that gets me 4 times negative 3 times 4. Our x terms, we have x squared. So that's going to give us x squared times x squared. And we have y squared and y to the 4th. So 4 times negative 3 is going to be negative 12, times 4 is going to be negative 48. And then x squared times x squared, same basis, we add the exponents. So we're going to have x to the 4th. And y squared times y to the 4th is going to be y to the 2 plus 4, or y to the 6th. So that is our next example. One more. Can you feel the excitement? Can you feel it? It's all down to this. Okay, do we have any? Yes, we do. Do we have any variables that don't have an exponent listed? Yep, k, so we'll make that k to the 1st. And what I'm going to do is I'm going to distribute the outer exponents. So it's going to go to my negative 3, to my j, to the k, and then 3 to the 2, to the j, to the k. So if we want to rewrite this, we're going to have negative 3 squared times j to the 2 times 2 times k to the 3 times 2. And that's our first factor. Next, we're going to have 2 to the 3rd and j to the 2 times 3 and k to the 1 times 3. Okay, if we have, just going straight across, negative 3 squared, that's negative 3 times negative 3. A negative times a negative is a positive, so we're just going to have 9. J to the 2 times 2 is j to the 4th. K to the 3 times 2 is going to be k to the 6th. And 2 cubed is 2 times 2, which is 4, times 2 again, which is 8. Pause for dramatic effect. J to the 2 times 3 is j to the 6th, and k to the 1 times 3 is k to the 3rd. Whew, keep going. Okay, we're going to group our coefficients together. So we're going to have 9 times 8. And again, as you guys get more comfortable with this, you won't necessarily need to rewrite it every single time. In order to hold myself accountable, I like to do this so that way I keep track of literally every coefficient and every variable I have. If we're dealing with our j variable, we have j variable there. So that gets us j to the 4th times j to the 6th. And last but not least, we have k to the 6th and k to the 3rd. Oops. K to the 6th times k to the 3rd. 9 times 8 gives us, remember those times tables? 72. J to the 4th times j to the 6th. Same basis, we add the exponent, j to the 4 plus 6, j to the 10th, and then k to the 6 plus 3, k to the 9th. And that is it. Congratulations, you have hopefully become a little bit more comfortable with multiplication properties of exponents. And now we're going to move on to topic 28 in our next one, division properties of exponents. I know you're all waiting for it.